Today we're going to talk about one of the most important theorems in all of mathematics. This is the Pythagorean theorem. You've probably been exposed to this in the past, but we just want to kind of go through this, make sure that everybody's on the same page and that we know how to apply the Pythagorean theorem. We are going to be doing this a lot over the next few weeks. So it's very important that we know how to do this. Okay, the theorem is that if I have a right triangle, okay, right triangle, this is for right triangles only, okay, the sum of the squares of the measures of the other two sides, then the angle opposite the longest side is a right angle, okay. We have a squared plus b squared equals c squared. Now, it's really important that we get this correct. We have a right triangle. The legs are A and B. The hypotenuse we're going to call C. The hypotenuse has to be the longest side because it's opposite a 90-degree angle. A and B are the legs. It doesn't matter which one of the legs are A or B. We square those sides. A squared plus B squared equals C squared. You should be able to solve this for the hypotenuse. You should be able to solve this for the legs. So Pythagorean theorem, a squared plus b squared equals c squared. You have to be careful to make sure you identify the hypotenuse first. Right? So always identify the hypotenuse. Okay, figure out which one's the hypotenuse. It's opposite the right angle. What do we mean by opposite? We'll draw a line straight through the angle. What side does it touch? Opposite side. Okay. So how do we apply this? Okay, so we have a right triangle here, side length 6, 8, and then the hypotenuse is x. So we're just going to set up the Pythagorean theorem. 6 squared plus 8 squared equals x squared. X is the hypotenuse. Now, when we solve this, okay, we have 36 plus 64 equals x squared. 100 equals x squared. How do we solve? We take the square roots of both sides. X equals plus or minus 10. Right. Now, doesn't make any sense to have a negative side length, so x is going to equal 10. So that side is 10. That hypotenuse has to be larger than all the other sides. Right. Now, really important with square roots. Make sure you're reviewing all your square root rules. One thing we'll see is if you see the square root of 6 squared plus 8 squared, you can't just get rid of the squares with the square root if there's a plus sign in between. You have to do the math inside the square root before you take the square root. One issue we see quite a lot, so please don't do that. Okay, so this is the Pythagorean theorem, okay? All right, so a couple things with the Pythagorean theorem. It only works for right triangles. So if a squared plus b squared equals c squared, then we know we have a right triangle. But by applying the Pythagorean theorem, we can tell whether we have an acute or an obtuse triangle. Now let's think about this. Let's say a is 5, b is 6, and c is 7. Okay, 5, 6, and 7. All those side lengths are pretty close together. We don't have one side that's a lot longer than the other side. So if I were to do 5 squared plus 6 squared and compare it to what we get with 7 squared, right? So we get 25 plus 36. Right, so we get a 61. 7 squared is 49. So the two smaller sides, when we square them, are greater than that third side when we square it. So this is going to give me an acute triangle, The reason is all those side lengths are very close together in length. If they're pretty close together in length, we're probably going to get an acute triangle. We're going to be dealing with this a lot when we start working with trig. Now, for an obtuse triangle. So obtuse triangle, we could have something like 5, 6, and 10. Why did I pick 10? Well, I know 5 plus 6 is 11. I know that third side has to be less than 11, so let's go with 10. Well, let's do the same thing. 5 squared, the two smaller sides, plus 6 squared. Compare that to 10 squared. Well, we know 5 squared plus 6 squared is 61. Well, 61 is now less than 100. 61 is less than 100. That means I'm going to have an obtuse triangle. And if you think about it, one side is quite a bit longer than the other two. So that's going to give us that larger angle opposite. So you take the two smaller sides and kind of set up that Pythagorean theorem and do a comparison. If the sides are, the legs are equal, so if I have 3, 4, and 5, 3 squared plus 4 squared equals 5 squared. We get 25 equals 25. We know that is a right triangle. So that is what we say the inverse of the Pythagorean theorem is how we know a triangle is right. So here's a couple of problems. Okay, find the perimeter of the rhombus. Okay, well, let's think back to last semester. What do we know about a rhombus and the diagonals? Well, the diagonals of a rhombus intersect at a right angle. Now, we have to be really careful here because as we've seen, we have a triangle that is a 3, 4, 5. And we'll see that quite a bit. But the 3 and the 4 have to be the legs. If we look at the triangle that we made here, I have 3 and 5. 5 is a leg. It is not the hypotenuse. We can't use the 3, 4, 5 triangle. So what we have to do is do 3 squared plus 5 squared equals b squared. So be careful with that b. b is not a leg. Right, so we have 9 plus 25. So that is 34 is b squared. Take the square root. So b is the square root of 34. Think about 34. Does it simplify? Well, 34 isn't divisible by 4. It's not divisible by 9. So it doesn't simplify. So if b is square root of 34, we have 4 sides. So the perimeter is just going to be 4 times square root of 34. And that would be my answer. So be careful. It may look like it's a 3, 4, 5, but it's not. So just be really careful. Make sure the 3 and the 4 are the legs, or the 3 and the 5 is the hypotenuse. All right, so let's see this one. PAT, is it a right triangle? Okay, well, if it's a right triangle, we can do 4 squared plus 9 squared equals 11 squared. 16 plus 81 is 121. Well, 16 and 81 is 97. 97 is less than 121. The answer is no, and it's actually obtuse. Because that longer side, right, when I square it, is greater than the other two sides when I add them up and square them. Okay, find the altitude. This is something we're going to be doing quite a lot, especially when we start doing area, volume, things like that. Well, how do we find altitude? Well, altitude, remember, is perpendicular. I'm going to drop a perpendicular down here. Let's drop another one on this side. All right, so I have 10 as my hypotenuse over here. We know inside these two altitudes is 20. So that gives me 5 left for each one of these. So there's a 5 there and a 5 there. Okay. So now how do we deal with this one? Well, let's do a Pythagorean theorem here. So we get 5 squared plus, let's call that altitude h. H squared is 10 squared. So I get 25 plus h squared equals 100. Subtract my 25. I get h squared equals 75. Take the square root, so I get square root of 75. Can I simplify that? Well, let's think about it. 75, I know, is 25 times 3. 25 is a perfect square, so that's going to be 5 square root of 3 would be my altitude. So that's how we calculate the altitude there. Pythagorean theorem, know how to do it really well. You are going to see a lot of square roots. Know how to work with those square roots.